Hi guys, after a long time I'm posting a science video. This video is going to be very interesting because I'm going to discuss about supernova. Why? Because we are stardust and everything on planet Earth, everything on this universe is made out of stardust. So what we see is basically stardust. You will know why. Supernova is when a massive star detonates and brings out a cosmic explosion, basically a giant into a star. Our star, that is our sun, will not face such a fate. For supernova to happen, it must at least be 8 times massive, more massive than our sun. The last minute of a death of a massive star will be the most cataclysmic event in this universe. Supernova is a cosmic recycling process where a massive star explodes and gushes out all necessary elements and atoms required to form new stars, planets, and building blocks for life. Our sky above is scattered with alluringly beautiful remnants of ancient supernovae. That is, stars lived out their lives and then died in a violent explosion. Our Milky Way galaxy may consist more than 300 billion stars, where we should be witnessing a supernova as often as 50 years. Yet, supernova visibility is exceedingly rare. You might or might not witness it during our lifetime. In our universe, there are approximately 2 trillion galaxies with average 200 billion stars. Each galaxy, we should be witnessing a supernova at least every year. Remember, guys, somewhere, some eons ago, some supernova led you to watch this video while I'm briefly describing about supernova. That is awesome. Now let me pass to my daughter.
Now, let's discuss the science behind a Type 2 supernova. For billions of years during a star's lifetime, nuclear fusion takes place, a process by which the lighter element, hydrogen, is converted into helium in the star's interior, in the process liberating huge amounts of energy, thus enabling the star to shine. For example, every star in a second fuses about 7.5 billion hydrogen, which is equal to 100 billion atomic bombs per second. This explosive energy during the fusion wants to tear up the star, but gravity is so powerful that it puts a lid on it. Here, we're not talking about the gravitational attraction of one object toward another, but about the star's own self-gravity. There is a continuous battle between gravity and outward pushing of energy, or radiation, from nuclear fusion. It's a duel of forces in which neither can be the victor. If the nuclear fusion at the core of the star is maintained, the star stays in balance. However, all stars are born with a finite amount of hydrogen fuel. After billions of years, changes begin to take place as hydrogen gets depleted, and finally the star completely runs out of hydrogen. Nuclear fusion will start to run out soon, and the star will have nothing left to burn. At that point, the star is no longer able to maintain its outward push against inward pulling of gravity. Gravity wins at the end. Before a star dies. In the core of a supermassive star, fusion of lighter elements turns into heavier elements. It happens faster and faster. The countdown to death begins as the inward push of gravity takes over as lighter elements, hydrogen, depletes and the core gets much, much hotter. This will start to fuse helium to carbon, which usually takes 1 million years. Helium too runs out and things will start speeding up. Carbon will be fused to neon in about 100 years, and neon fusing with silicon takes about 1 year. Once silicon starts to fuse into iron, it takes just 1 day. Once iron starts to fuse, the star is in a death rope. The iron sphere in the core will be several miles across and unbelievably hot, like 1 million degrees. Once iron is fully created, there is not much of a fusion because the iron will start to steal the energy. Gravity will pull in and everything will be crushed into a small region. The star is doomed, and the core collapses so fast with trillions, trillions, and trillions of gas falling into the core. Breakout happens first when the star collapses. There is a shock wave. It is the signal that the star is about to explode. The shock wave breaks out like a tremendous amount of energy getting released at top speed. Witnessing a shock wave. The Argentinian amateur astronomer wins a cosmic lottery. Victor Busseau, on September 20th, 2016, picked the right patch of sky for his camera testing. He was using his camera affixed to his 16-inch, 41 centimeters telescope. For his luck, his telescope was focused on a spiral galaxy called NGC 613. The galaxy is around 85 million light-years away from the Earth. In the southern sky, he spotted a rapidly brightening blotch of light in the series of images he was taking. What he saw was a shocking breakout before the main event. An object brightening very quickly for a short time, were a shock wave of supersonic waves going through the star and bursting out of its surface. Huge amounts of energy are released at a tremendous flash, or a moment of shock breakout. A shock breakout is like a cosmic gold dust that lasts for 20 minutes. A blink of an eye in an astronomical timescale. Remember, this is the bounce before the blast. A fun fact: a supernova can outshine the entire galaxy with over 100 billion stars. The remnant from supernova lights up the universe. They are crucial because from the blast, many ingredients such as sulfur, carbon, oxygen, and even elements necessary to build planets and building blocks come to life.
Okay, guys, now the question starts. Are we the children of stars? Our DNA molecules are made up of materials that was part of a massive star's core. An individual star lives out its life. They enrich the universe with new atoms and chemicals. Those go on to form newer stars like our suns, planets, and building blocks for life. Dust blows out from the explosions, forming a spectacular interstellar cloud, which we call nebulae. They are the nursery for stars, where gravity kicks in and stars form, including our solar system. Supernova produces a very rare radioactive element called iron 60. Scientists have discovered several evidence where iron 60 is embedded in Earth and other planets, moons in our solar system, sprinkled like a radioactive salt. These radioactive elements are found on Earth and other planets are direct evidence that a supernova led to the formation of our solar system 4.6 billion years ago. In addition, there is a conclusive proof that a supernova may have made us. Roughly about 2.5 million years ago, a star has blasted nearby, leaving iron 60 in many of the fossils and sedimentary rocks on Earth. Geological and biological studies revealed that life on Earth changed dramatically during this time. Africa lost much of its forest and green, with various plants, animals went extinct. Also led to formation of new species. A nearby supernova lethal gamma rays damaged our ozone layer. There was no ultraviolet protection that led to mutations. Also led to the evolution of hominoids and then Homo sapiens. Scientists believe, based on evidence, that human evolution took shape roughly after 2.5 million years.
Ending note: in around 10 billion years, our sun, although our sun isn't massive enough to produce a supernova, will become a red giant and eventually become a white dwarf star. For a supernova, a star must be at least over 8 solar masses. The remnants of a supernova may become a neutron star, roughly 12 miles in diameter, or a black hole, or a totally new and final phase in its evolution. After weeks or months, the glow of the supernova slowly fades from view, finally snuffing out altogether. So, what happens to the material flung into space in a supernova explosion? The remains of the star? It disperses gently over the eons, and its elements go towards forming new stars, new planets, perhaps even new life. All the atoms in your body were forged in the fiery hearts of ancient stars. The calcium in your bones, the iron in your blood, all were born from a death of a huge red giant star and seeded across the universe in a supernova explosion billions of years ago. We are from Stardust. We owe our lives to the death of a star. Thank you for watching. Please share this video and spread science to everyone because it's more important than you could ever know. Please subscribe if you haven't and click the bell icon. Cheers. Bye.